In the diagram, triangle ACD is drawn with points A and D on the circumference of the circle. CD cuts the circle at B. P is a point on AD with CP the bisector of angle ACD. CP cuts the chord AB at T. AT is equals to TP. Angle ATP is equals to 65 degrees and angle PCD is equals to 25 degrees. Find the size of D. So we're looking for this angle over here. And how would we go about that? So what we can do is try to find as many angles as we can. So here we're given 65 and we're given the angle 25. From 65 I can say that T3 is equal to 65 degrees. This is because of vertically opposite angles. Then we can also say that B2 is equals to 25 plus 65. So B2 is this angle over here. And we are saying that B2 is equal to 25. Let's write that down. B2 is equals to 25 plus 65, which is equals to 90 degrees. So why are we saying that B2 is equals to 25 plus 65? Well, that's because we have the B2 as an exterior angle to triangle BCT, which has internal angles 25 and the 65 which is found. So B2 is equals to 90 degrees because it's the exterior angle of a triangle. Then we now have the angle B2. Now we can also say that P2 is equals to 65 degrees. This is because these are base angles for this triangle. If you see triangle ATP, this side is equal to that side. So 65, P2 will also be 65. So this is property of an isosceles triangle. Then once we have P2, we can also say now that A2 is equal to 180 minus 2 times 65, which will be equal to 50 degrees. So here we're saying A2 is equals to 180 minus 2 times 65. That will give us 50 degrees. And once we have that, we now have B2, we now have A2, and now we can find D. So let me just put the reason for A. That's the interior angles of a triangle. They add up to 180. So now lastly, we're going to say that D is equal to 180 minus 90 and minus 50, which will be equal to 40 degrees. And this again is also interior angles of a triangle. And our answer here is 40.